My name is Partho Das, Assistant Professor, Department of Electrical Engineering, JIS College of Engineering, West Bengal, India. So welcome to my class. So as you can see, the today's topic is the parallel operation of alternator and the load sharing. So in the previous classes, I have discussed about the alternator construction, working principle, then the excitation methods, then the EMF equations, then the phasor diagrams, equivalent circuit diagram. So all those things are the theoretical background of a machine. But if we think of where we actually use this alternator, so those alternators are actually used in the power generating station. So whatever is the kind of power generating station, maybe thermal, maybe hydel, maybe nuclear, maybe diesel, whatever is the generating station, so there we generally use those kind of synchronous generator. And we know this huge amount is power nowadays are generated by only those alternators or synchronous generators. Now after generation of this electric power, so they are transmitted by some transmission lines from the generating station, and then it is coming to some substation, and from substation it is distributed according to the area. And then we have what we have, then we have that then there is a distribution, maybe single phase distribution, maybe three phase distribution. Generally in domestic purpose we actually use the single phase, and in case of industry or in case of industry actually also there we use the three phase supply, that is of 440 like 11 kilovolt, like that way we use there. But the point is that that means I want to say you that we are the consumers, we are actually consuming that power. So now we we are paying to the electricity boards, different there are government electricity boards and there are private electricity boards, different boards are there. Now the point is, when we are paying to the electricity board, so we what we want that 24 into 7 electricity. So we want uninterrupted power supply to us. But it may happen that, so suppose say some X place there is a generating station, from that generating station power is coming to my home. Okay, so now in that generating station, due to some reason there is a fault occurs in the alternators, or some so due to natural calamities there is a sudden shutdown in the power generating station. So then what will do, what will happen? So there will be no electricity at my home, but I am paying to you, I am paying to the electricity boards. So the consumers always need, not my point is always the consumers, who the person, those who are consuming powers, always need 24 into 7 electricity. That means the uninterrupted electricity. So to do that, what we can do, so say there is a generating station and there is the consumer. So if there is any problem in the generating station, this consumer can be affected. Now the point is, say A, B, C, D, so like that way different generating station are connected together to form power pool. That means that is the concept of the grid, national grid. So in India we have a national grid. So in national grid, see in our India different states are there. So different states are generating electricity by themselves, by in each state has some government sector, some private sector, those who are generating some electricity. And now as per the government rules, all generating station have to give some connection to the national grid. So as in the demand, say there is a West Bengal and there is a Bihar, though both are connected by some common grid line. Okay, so now in Bihar, say there are some problems, or in West Bengal there are some problems. So what will happen? So there is a lack of energy. So now this grid system, the authority of this grid will buy the electricity from the Bihar, if this Bihar have a its extra generation with respect to its demand. Okay, then that extra energy will be carried out from Bihar to the national grid, and from national grid it will carry to the West Bengal to the customers of the West Bengal. So like this way, so there is a system where all the generating station of different areas are connected together to give the consumers uninterrupted power supply. So this is the parallel operation actually. So now we have to think of that, okay, uh, like this way we can overcome the problem by by connecting parallel different alternators to share the loads. But what are the conditions by which we can connect? What are the conditions we have to check, and then we can connect running alternator with the incoming alternator. Okay, so those things we have to know now. Or that means the physics or the engineering behind this one, that we have to know. Okay, so coming to the next slide. Okay, so in this particular presentation, what we are going to cover, those are the topics, contents are given here. So what are the contents? There's the introduction already told to you, why this system is required, parallel operation of alternators, parallel alternators arrangement, how we can arrange the alternators together in parallel process, the conditions of parallel operation, application where we can use this system, advantages, and summary and references. So those are the things that we will cover in this particular presentation. Okay, so coming to the next slide. Okay, so as I am telling you that consumers always need uninterrupted power supply, so basic need is this one for the parallel operation. And somehow it is needed that in the transmission line there should not be there should always should be there always should be some level of power should be there, so that if there is a sudden rise in the load demand, so that can be uh, satisfied by this interconnection system. So these are the main reason, already I have discussed with you what are the reason behind this parallel operation of the alternator. So as you can see over there, it is necessary to provide an uninterrupted continuous power supply. In case of an isolated plant, a considerable amount of reserve capacity would be required to ensure the continuity of the supply. Yes, very important thing is that one, that if a power plant is an isolated one, then it has that capacity so that it can store some energy. And how we can store some energy? Generally we use some battery over there, so it has a high cost, but it is not economic at all. Okay, so that's why there is the interconnected system. If there is a problem, other one is there. If this there is a problem, the other one was there. So like this concept is considered over here. So moreover, some units are required either to lightly loaded or floating on the lines in order to meet the unpredicted sudden increase in demand. So already I have discussed with you that one. So there will be two or more alternators connected in parallel, called parallel connection of alternators. So that thing we are discussing. Okay, the parallel operation of power station is essentially an extension of parallel operation of alternators, with the expectation of resistance and reactance of the interconnection. So one more thing is there. So say in a power plant, 5 alternators are there, 5 alternators are generating energy. So that 5 alternators connected together parallelly, and that system is connected to the grid system. And like this way, all generating station has some numbers of alternators, they are connected in parallel, and those are together, though 2 3 power generating station are again, they are parallel to each other, and they are connected to the national grid system. So like this way, all are connected parallel. So there are many more advantages. So if we connect parallelly, or the alternator, so that the system resistance, the transmission line resistance, or the circuit resistance reactant can be minimized. Okay, so the maximum number, huge numbers of power can be delivered from one location to another location. Okay, so why this system is required? Uninterrupted continuous power supply, already discussed with you. For fulfill the load requirement, yes, definitely. Provide increase the overall efficiency, definitely. When the resistance, reactance, those things, the loss and drops are minimized, that means the efficiency is definitely increasing. For reduced power unit generation cost, Yes. So see, one thing is there. um this in, say, in India there are the different kinds of location. So some are the hill areas, some are the um, uh, flat areas. So different areas are there in India. So in different areas the availability of the um, element by which we are going to uh, generate electricity, that those are different, correct. So in, say, in the uh, area like in West Bengal we have like Durgapur, Asansol area where the coal availability is high. So there the thermal power plant is easier to make, and from those areas we can bring coal to our areas in the like Bandel, the Kolaghat, or the Chichago. So like those areas are there where we can bring the coal, and from that we can burn, we can generate the thermal electricity. So those plants are the thermal power plant. In if we think of a hill area, so there we have a hydral power plant, because there is a nature is there, the water is flowing at some high speed. So we can use that one, we can do that one. So different areas, suppose now, say, we want, if we want to plant a hydel power station at Kolkata, is it possible? No. Why no? Because there is no inclination. If there is no inclination, so there will be no water speed. So uh, we have to make that, we have to man made that, but that is not required. So my point is, depending upon the availability of the element by which we are going to um, introduce we generate the energy. So depending upon that we can planning for a generating plant, and then only the total generation cost will be minimized. And if after that it is connected to the grid system or parallelly connected, then the overall cost can be minimized. So these are the things why we need this parallel operation. Okay. So for parallel operation, the easiest way to set up parallel system is to use alternators that are exactly alike, or at least have the same output rating and alternator pitch. So these are the things, that the points that we have to take in the consideration when we are connecting two, three, or more numbers of n numbers of alternators in parallel. Another flexible pitch to backing up your power requirement is to have two or more alternators of variable output. Very important point. In either scenario, they can be connected in parallel with paralleling switch gear to achieve maximum output during peak requirement, or the desired minimal output during other times. So when we are paralleling all the generators, all the alternators together, so we can think of that in a 24 hours of a day. So there are different times, and different times are low, different in the if we think of the midnight, so load demand is very less. If we think of the um, 1 p.m. or 2 p.m. or 3 p.m. or in the evening time, there is a huge load demand. So depending upon time, so we can think of that when there is a high demand, all the alternators are connecting together to meet that load demand. And when it is a lowest demand, at that time, so one two alternators all are connected in parallel, but one two are working to meet that load demand. So like this way we can optimize the operation of all the alternators, so that one alternator should be run sometimes at the peak load, one should alternator should be done at sometimes at the base load. So that the maintenance of the alternators can be done if we do the parallel operation. Yes, it is a diagram of two alternators connected to the bus bars. So follow my pointer, I am going to explain with you this diagram. So these two follow my pointer, these are the two bus bar. Okay. So and these are the two generators. Okay, this is, sorry, this one. So this is one generator, this is the second generator. Both we have to connect to the bus bar. Okay. So how we have to connect to the bus bar? Through some switch gear. And when we are connecting that two alternator to the bus bar, we have to check the voltage level. That's why there is a voltmeter connection. And then also we have to consider the phase sequence, otherwise we cannot connect, there is a faulty condition may occur. So we have to check the phase sequence and voltage level and frequency. Those are the things that we have to check when we are connecting. And one more thing is there, and that is there are different methods we can use by which we can um, connect the incoming alternator to the running system, or the to the bus system. So though that method is known as a synchronizing method. Okay, so in the after this presentation, in the next presentation, I am going to discuss with you what are the different types of synchronizing methods we have. Okay, so these are the things. So next, coming to the next presentation process, how now the point is how we are connecting. Okay, already I have discussed little bit. Now let us see what is written over here. In the operation, there are two alternators connected in parallel. Correct. Two bus bars to which the number of alternators should be connected. The process of connecting an alternator in parallel with another alternator in which common bus bar is called the synchronizing. Okay, the system is established on the base of requirement of the load. So that means if we have a very low load demand, that means, so we will not connect huge numbers of alternators to there. If there is a low demand, so less numbers of alternators should be connected. If there is a high load demand, so n numbers can be alternators can be connected to the bus bar. Okay, and there are different synchronizing methods also. Three dark lamp method, two bright, one dark lamp method, synchroscope. So different methods are there by which we can synchronize and we can connect alternator to the system. Okay, now it is very important point, that is what is the condition to make the alternators connected to the existing system, where already a bus bar is there, and with that bus bar, say n numbers of connectors are connected. Now another alternator we have to connect with this one. So how we can connect that thing, we have to understood right now. For make system efficient and free from dangerous problem, then some conditions are required. What are the conditions? The terminal voltage of the incoming alternator must be equal to the another alternator. Those are connected to the bus bar. That means whatever alternators we have to connect it, all output have the same voltage rating, that is a kVA rating. Okay, then the frequency, that say one alternator is generating frequency of 50, another is generating 60. So then if we cannot connect, because both they will not synchronize with each other, though as the frequencies are different. Okay, so when we are thinking of that one alternator we have to connect to the bus bar, so we have to think of what is the frequency level of that bus bar, and according to that we have to set the frequency, we have to set the frequency of the alternator, and that then we can connect to the running bus bar system. Okay, both alternators voltage are same, or the bus bar voltage related to the load. Correct, already discussed. No circulating current between the winding and bus bar and the incoming alternator. There should be no circulating current. Okay, if there is any circulating current, then that will make some problem, make some may there is some accident in the system. So we should not any circulating current should not be there. Okay, phase sequence must be same. So that means with A phase we should connect A phase, with B phase we should connect B phase, with C phase we can connect C phase, and the phase sequence, one would be in positive half, one negative half. No, that cannot be possible. So we have to check the phase sequence, and then we have to connect. So these are the main things how we can do the parallel operation. Now the application. Okay, so power plants, we apply those things in industries and load sharing. There we industries we do these things, and others application. Advantages, these are the important point. What are the advantages? The advantages is we can share the load. So if we think of that, one, say one alternator is enough to give to meet the power demand of some load demand. Okay, now for that particular alternator, it is if it is running at all the time at full load, so a huge heat can be generated inside that, and due to that the longevity of that alternator will be minimized. So to for the longevity and uninterruption power supply to the load demand, so we can share that load to in between 2 3 alternators, so that one alternator should not always run at its full load or overload. Okay, so efficiency, yes, as the system, when we are thinking of all the alternators are connected parallel to the bus bar, so the synchronous reactance and the resistance of the system can be minimized, so the overall efficiency will be increased. Reduce losses, yes, already told. Easy to operate, yes. So if we consider those points, that this things we have to take into consideration, conditions we have to apply, then it is very easy to operate. Cheaper, already discussed with you. Continuity of supply, this is the main thing we have to take care of, that we as a customer, we need uninterrupted power supply, and for that we need this kind of system. Okay, save of fuel, obviously. So other many advantages are there also. So it is very advantageous for all kinds of industries actually, where our emergency services, where we need always uninterrupted power supply. If there is any interruption, there is a huge loss, maybe some material loss, maybe some manufacturing industry there are some loss, maybe some medical industry there may be human damage may be there. So we can overcome those problems with paralleling those alternators. Okay, so these are the things that I have to discuss with you. And so now this is the summary. In the parallel operation of alternators, we have learned about the whole system and know the main advantage by this, and we do in our electric system. Here we also studied about the process of parallel operation and the application of this types of system. Behind of everything, there are one more term is why, and here we know about this and how we utilize it in our system, and what are the main work for complete the task of electricity. Okay, so that thing is summarized, why we use this, how we use this, where we use this, what are the advantages of this. Those are the summarization that we have discussed over today. So this is all for today. Thank you.